Welcome and thank you for tuning in. Today we're going to be working on solving square equations. So right now, let's go ahead and get started on our first example. It says here, x squared equals 36. Well, first of all, I want you to understand, it is always going to be our goal to isolate x, or whatever variable it may be. And the way we normally do that is by doing the inverse operations. So here, we have x squared. It's almost isolated, but the square is in the way. So in order to isolate that, I'm going to do the inverse of square, which is going to be the square root. So I'm going to go ahead and take the square root of both sides, which is going to leave me with x equals, well, the square root of 36 is going to be a positive and a negative 6. Now let me prove to you why I included a negative 6. I know 6 times 6 is 36, but negative 6 times negative 6 is also positive 36 because a negative times a negative is a positive. So one thing that you want to be very careful about is when you give an answer, you make sure you include a positive and a negative answer. So if you do it on your homework, if you only put 6, you'll only get partial credit, and especially on a quiz or a test, you want to make sure you include that. Now moving on to our second example. So here it says x squared minus 13 equals 36. This one's very similar to the last one, except there's one additional term. It's this term right here, which is called the constant. So what I'm going to do is go ahead and get rid of that first by adding 13 to both sides, which will leave me with x squared. Well, first of all, negative 13 plus 13 is 0, so that goes away, equals 36 plus 13 is 49. Now, in order to solve for x and isolate it, I'm going to again have to take the square root of both sides, leaving me with x equals, and again, please make sure you remember to include a positive and negative 7. Now moving on to our third example. So this one's almost identical to our last example, so you're probably wondering why I'm showing you this one. Well, let's see what happens. Here again, I have a constant so that I'm going to have to get rid of. And the way I do that is by doing the inverse of adding 50, which would be to subtract 50 from both sides. So here, now I'm left with x squared. These cancel each other out, leaving me with x squared equals negative 48. In order to isolate x, I'm going to have to take the square root of both sides. And now I'm left with the square root of x is x. Now, how do I find the square root of a negative number? What could I do to multiply a number by itself to give me a negative number? Is it possible? The answer is no. And let me prove it to you. Let's use the number 2. 2 times 2 is 4. So it's positive. Okay, well, what if I wanted to try a negative 2? A negative 2 multiplied by itself, so negative 2, will still give me a positive 4. So those are my only options. You can square a positive number or square a negative number. There's no way that after I square a number, it will give me a negative number. So here, there is no solution. So your answer will be no solution. So please beware that there are equations like this where there will be no solution, so be on the lookout. For our fourth example, this is the type of problem that generally tends to scare students, and the only reason why is because there's a fraction involved. But I'm going to show you how to overcome that fear. So here, let's take a look at number 4. It says x squared over 2 equals 32. What could I do to get rid of this 2 because I want to get this to be a whole number? I don't like working with fractions. Well, the first thing I would suggest to you is to read this equation in terms of operation. So what do I mean by that? Well, you could read it as x squared over 2, or you can read it as x squared divided by 2. Well, why would I want to do that? By identifying the operation as division, I can now do the inverse operation to get rid of the 2. So if I'm dividing by 2, the inverse operation would be to multiply by 2. So notice here, I'm putting it 2 over 1 because then I can see how the 2's cancel each other out. I'm going to go ahead and multiply by 2 on this side, and it's going to leave me with x squared equals 64. I'm not done yet. I still need to take the square root of both sides to isolate x, which is going to leave me with x equals positive and negative 8. Again, please make sure you include both positive and negative answers when you're taking the square root of it. Moving on to our fifth example. So again, we see that there's a fraction, but now we know how to get rid of it, so we shouldn't freak out. Here, I'm going to see that I have a constant again. So I actually want to get rid of the constant before I get rid of this, which is called the coefficient. So I'm going to go ahead and subtract 22 because the inverse of adding 22 is subtracting 22, which will leave me with x squared divided by 3 equals 25 minus 22 is 3. Now here, again, I want to get rid of this fraction. So how do I do that? Well, it's x squared divided by 3. So the inverse would be to multiply by 3. If I multiply both sides by 3, the 3's cancel out there, leaving me with x squared equals 9. So how do I solve for x? Well, take the square root of both sides, and I'm going to get x equals positive and negative 3. And that's it. Okay, moving on to our last example. We're almost done. So now here we have negative 3x plus 22 equals negative 125. What you first want to do is go ahead and get rid of the constant. So I'm going to subtract 22 from both sides, leaving me with negative 3x squared. This cancels out, leaving me with negative 147. Now, in order to isolate, I'm going to go ahead and get rid of the 3 by dividing both sides, but a negative 3, leaving me with x squared equals, let's see, 3 goes into 14 about 4 times with a remainder of 2, and that will go in 9 times. I'm going to take the square root of both sides, leaving me with x equals positive and negative 7. And that concludes our lesson. We went ahead and solved square equations. Thank you for tuning in.